at the end of this topic, you should be able to determine the optimum solution of a transportation problem using modified distribution method, which is also known as MODI method or UV method. We need to have a basic feasible solution so that we can apply the MODI method. Now, what is basic feasible solution? A basic feasible solution of a transportation problem is the solution which satisfies all the constraint, that is supply constraint and demand constraint, and that can be obtained with the help of any of these three methods. The first method is northwest corner method, least cost method, and Vogel's approximation method or penalty cost method. Now in this video we are not going to cover the evaluation of basic feasible solution. You can watch my other video to get this solution, and we are going to use the MODI method to get the optimum solution based on the solution available here. You can refer other videos for getting the basic feasible solution. This is the first step in order to apply the MODI method. We will not go in details of step 2 and step 3 and further steps. Rather, we will try to understand these steps with the help of one example. So, the statement of a problem is like this. There are 3 factories located at different locations supplying products to various 5 retail agencies. So 3 factories which are the source factories, and they are supplying products to the 5 destinations, that is to 5 retail agencies. Cost of unit product transportation is given in the following matrix. Okay, so what is this 1 represent? 1 represents the cost of transporting one atom from factory F1 to destination A1, right? Okay, or this 9 represents the cost of transporting one product from F1 to A2, and likewise. And we have been asked to determine the total transportation cost with the help of modified distribution method. Now this is a transportation problem, and we have to determine the transportation cost, rather minimum transportation cost, which will be required to transport all the available supply to the destination. Now let us see, one more example is given, one more information is given in this problem, that is what is the capacity of each factory. Now this F1 factory have a capacity of 50, F2 is having the capacity of 100, and F3 is having the capacity of 150. What is meant by this? That this F1 can supply 50 number of goods to either A1, A2, A3, A4 or A5. Okay. Similarly, this F2 can supply 100 number of goods to either A1, A2, A3, A4 and A5, and corresponding cost of unit product transportation are given over here. And this F3, that is factory 3 or source number 3, can supply up to maximum 150 products to any of these retail agencies. Now we have to come up with the distribution of these products so that the cost will be minimum. What more information is given, that what is the demand of this A1? So A1 wants only 100 products, right? A2 wants 70 products, A3 wants 50 products, A4 wants 40 products, and A5 wants 40 products. Okay, now whenever we wish to solve the transportation problem, it is very essential to check one thing, that whether the problem is balanced problem or unbalanced problem. Now here you can see that total of all these capacities, or which is also called as a supply, is 300, and this total of this all the demands, or which is also called as an requirements, is also 300. Okay, so my demand and supply are exactly matching, so this problem is a balanced transportation problem. If it is not a balanced transportation problem, then we have to take a different approach. Now, the basic feasible solution is already obtained, and we are directly taking this basic feasible solution which is obtained by the least cost method. Now, if you're not aware of this, what is the least cost method, please refer to the video given in the description section, because it is essential to get the basic feasible solution, and then only we can use the MODI method to get the optimum solution. So what is this basic feasible solution is that I will supply 50 number of goods from F1 to A1, right? So then I will supply 60 number of goods from F2 to A2 and 40 number of goods from F2 to A5, and I will supply 50 number of goods from F3 to A1, 10 number of goods from F3 to A2, 50 number of goods from F3 to A3, and 40 numbers of goods from F3 to A4. So this is the direct solution which I have obtained with the least cost method, and I am using it directly. Now here is a question for you, whether this solution satisfies the row and demand constraint. Now let us see whether it satisfies the demand and supply constraint. So if you calculate this row, okay, so here is 0 0 0 0, right? So this 50 is equal to 50, so I can say that this constraint is satisfied. So this 60 plus 40 gives me 100, okay, which is equivalent to this 100. So I can say that this row constraint is also satisfied. Again, 50 plus 10 plus 50 plus 40, which gives me 150. So I can say that all the all the supply constraint or capacity constraint have been satisfied. Similarly, we can look for the columns. So this 50 plus 50 give me 100. So yes, it is satisfied. 60 plus 10, 70. Yes, it is satisfied. 50 equal to 50. Yes, it is satisfied. 40, 40, and this 40 and this 40. So eventually we can say that the row constraint and column constraint or supply constraint and demand constraint have been satisfied. Now we can move towards calculating the optimum solution or least cost with the help of MODI method. Before we apply the MODI method, it is very essential to verify the number of allocations. So what I mean by number of allocations? So here I can say that how many number of allocations I have made. So I have made 1, 2, 3, 4, 5, 6 and 7 number of allocations. And this number of allocations should be equal to m plus n minus 1. So I have how many number of allocations? 7 number of allocations, and let us see how do we calculate this m plus n minus 1. So what is m? M is number of rows, so which is equal to 3. N is number of columns, which is equal to 5. So 3 plus 5, 8 minus 1, which is equal to 7. Okay, and the number of allocations over here were also 7. So we can apply the MODI method because we satisfy this condition. Moving to the next one. Now we are ready to apply the MODI method. Now you need to prepare this kind of an matrix in order to apply the MODI method. So this is our matrix which we got with the help of least cost method. Right, so F1, F2, F3 are your factories, A1, A2, A3, A4, A5 are your destinations. Okay, and this 50, 60, 40, these are the allocations made with the help of least cost method, and this 1, 9 are the cost or unit transportation cost which are mentioned in the problem. To this, what I have done, I have added these dual variables. So I have added how many dual variables, which are equal to number of rows and number of columns. So I have added u1, u2, u3, right? So 3 variables as there are 3 rows, right? And v1, v2, v3, v4 and v5 dual variables equal to the number of columns. I am going to use certain formula and certain procedure which we need to follow to proceed with this method. Now the first and most important thing is that we have to concentrate on the cells which are having certain allocations. So there are 1, 2, 3, 4, 5, 6 and 7 cells which are having allocations. So we call them as an allocation cell. So we will concentrate on this allocation cell. So I am writing this formula u1 plus v1 is equal to 1. So now let us try to understand what is u1. So u1 is the variable, dual variable corresponding to the first row. v1 is the variable corresponding to the first column, right? And this 1 represents the unit transportation cost, right? Okay, so which is given in the problem. Okay, now why I have considered this cell? Because this is an allocated cell. I cannot apply this formula over here in this cell, right? So I can apply this formula only in the cell where I have allocations. Okay, now initially what I will assume that u1 is equal to 0. Okay, so if I put this u1 value in this formula, I will get v1 is equal to 1, right? Okay, now we have to select now such a cell where we can obtain the values of remaining things. So what I will do, I will select now this cell, right? Because the one variable is already known and the other variable I can calculate. So what will be the formula for this now? It will be u3. So this is my u3. Now concentrate to this cell. This is an occupied cell or assigned cell, right? Where we have allocation. So this is u3, right? And this is v1, right? And which is equal to 14. Okay, so I know the value of v1, right? And I know this 14, so I can calculate u3. So what will be the u3 in that case? So u3 will be 13. So I have got 3 dual variables value, and I need to calculate all the values for this dual variables. Now next I will go to the such a cell, okay, where I already know one variable and I wish to calculate the other variable. So if I go to this cell here, I already know u3 and I can calculate the v2. So what will be the formula in this case? So u3 plus v2, right? So corresponding to this, right, is equal to 33. Okay, so I know u3 and I need to calculate the v2. Okay, so what will be the v2? v2 will come is equal to 20. Now the next cell where I can go is this cell. So I can write the formula as u2 corresponding this u2 plus v2 is equal to 12. So I know the v2 is equal to 20, so I can calculate the u2 as minus 8. Now I will go to this cell because I know already this value of u3, right? So how can I write down the formula? u3 plus v3 is equal to 1. So what is 1? This is 1 is the corresponding value of an unit transportation cost. So u3 I know 13, right? And I can calculate the v3. So v3 will come as a minus 12. Now from this cell I can move to this cell, right? Because I know one value as u3. So okay, so u3, so corresponding u3 plus v4 is equal to 23, right? So I can get value of v4 as 10. Now moving toward the last cell, so I can write down that for this cell, right? Because I know the value of u2 and I want to calculate the value of v5. So u2 plus v5 is equal to 1. So that gives me the value of v5 as 9. So almost we have got the values for all the 12 variables. Now moving to the next point. For the sake of our convenience, I will remove the allocation. So I was having allocation over here. So I will remove this allocation and put a dot over here, right? So this is for our convenience. So I'm putting a dot over here to avoid the further confusion. Now we need to calculate the opportunity cost, right? So what is an opportunity cost? Let us see. So OC is an opportunity cost, if OC of each cell is either positive or 0, okay, initial feasible solution is the optimum solution. However, if the OC for any cell is negative, the initial feasible solution is not an optimum solution. So what we are going to do, we are going to calculate the opportunity cost, right? So is there any opportunity in allocating to this empty cell, because this is an empty cell now, right? So all these are empty cells, right, which are not occupied. So I'm going to see any opportunity, right, where if I transport something at this place, right, okay, so will it reduce the transportation cost? So if opportunity cost is positive or 0, right, okay, so the initial feasible solution will be optimum. Otherwise, if it is negative, okay, it is not an optimum solution and we have to make the allocation at that point. So moving toward the next thing, we are ready to calculate the opportunity cost. We need to calculate the opportunity cost for the empty cell. So this is our first empty cell for which we will calculate an opportunity cost. Opportunity cost is given by this formula. So this formula says that C12. So what is C12? C12 corresponds to the first row and second column and the cost at that cell. So 9 is the value, right? Minus corresponding U1, right? So corresponding U1 and minus V2, right? So this formula gives me the opportunity cost. So if I put the values over here, right, so C12 is nothing but the 9 value, that is the transportation cost. U1 we have calculated, that is 0, and V2 that we also calculated, that is 20, and this gives me a minus 11. So this is an opportunity cost for this cell. Now let us calculate the opportunity cost for the next empty cell. So this is the next empty cell. So the formula will be given by C13 minus U1 V3. So what is C13? C13 is the unit transportation cost at this point, right? And U1, this is the corresponding U1 value and corresponding V3 value. So if I put all these values over here, so I will get 13 minus 0 minus 12. So that gives me the value of 25. So 25 is nothing but an opportunity cost. Now I have a question for you. Can you calculate the value of opportunity cost for the remaining empty cells? So pause the video and try to find out the answer for the remaining cells. So I hope that you must have given the try. So let us see whether your answers are correct or not. So these are the values you will get for the remaining empty cells, and I will calculate the last value for your reference, right? So I need to calculate this opportunity cost at this cell. So what is the formula? So how do I get this formula? So C13, so C13 is nothing but this 26 minus corresponding U3 minus V5. So that will give me the value of 26. So this is 26 minus this 13 minus this 9 will give me the value of 4. Okay, so I have got all the opportunity cost for all the empty cells. Now I can notice that this is the only negative value I got. All other opportunity costs are positive. What is the meaning of this? The meaning is that we have an opportunity at this point. So I have marked star over here at this cell because we found out that opportunity cost for this cell was only negative and for other empty cells it was positive. So if you want to allocate something at this cell, we have to find out the loop, right? So what is meant by loop? Let us see. Now loop be at this cell, right, and see either horizontally or vertically where you will get the next allocation. So if I look from this cell, so if I move to the horizontal direction, I don't get any allocation, right? If I move to the vertical direction, I will get certain allocations. So I will move vertically. So if I go from this cell to this cell I have a one allocation, right? Now I can move to the this direction, right? And here I will get one more allocation. If I move again to the upward direction, I will get one more allocation, and I can come back to the my original position. So this has created a loop for me, right? And this loop is very important, right? Now what is the importance of this loop? Now let us say that I have allocated one unit. If I have allocated one unit at this cell, right? Okay, and if I remove one unit at this cell, right, and I can also add one unit at this cell, right, and I can remove one unit from this cell, right? Okay, and it will balance all the demand and supply constraint. So this is the importance of this loop. When you will allocate one over here, you have to remove one from this cell, and you need to add one to this cell, and you need to remove one to this cell. Now to see how much I can allocate to this cell, look for the cells which are having a negative sign. So this is a -1 and this is the -1. And what is the minimum out of these two minus cells? So this is the cell which is having the minimum value of allocation. Okay, so I can move 10 number of goods in this loop, so that to avoid any negative value at this point, right? If you remember, this is our initial allocation, right? And we have identified this cell as an cell having negative value of an opportunity cost. So what was the total transportation cost with this cell? So I can calculate this total transportation cost for the cell which we got with the help of least cost method as 2810. Now how did I calculate that? So I calculated it by 50 into 1 plus 60 into 12 plus 40 into 1 plus 50 into 14 plus 10 into 33 plus 50 into 1 plus 40 into 23, and that given me value as 2810. Now what I will do, I will allocate the maximum possible over here. I am allocating 10 products over here and this will reduce to 40, and this 10 will be reduced to 0 over here, and this 50 will be reduced to increase to 60. So let us see, with this allocation do I satisfy the demand constraint and supply constraint. So 40 plus 10 will give me 50, right? So 60 plus 40 give me 100, and this 60 plus 50 plus 40 gives me 150. So I am satisfying the row constraint. So looking for the column constraint, 40 plus 60 will give me 10, 100. So 60 plus 10 will give me 70. So this 50 equal to 50, 40 equal to 40, and this 40 equal to 40. So again I am satisfying the column constraint also. So now here is a question for you. Can you calculate the transportation cost for this? So stop the video and try to calculate the transportation cost. Now I hope that you must have given a try. So the transportation cost is calculated as 2700. Now you can see that their transportation cost is reduced from 2810 to 2710, and the reduction is cost is 110, right? Now but this is not the end of problem. Now what is the solution that we have got with this UV method? We need to verify whether this is the only final solution or optimum solution. And how do we can find out that? By again calculating the opportunity cost. And if all the opportunity costs are positive, right, for this all empty cells, then only we can say that the present solution is the optimum solution. So let us calculate the values of u1, u2, u3 and v1, v2, v3, v4 and v5 one more time. So what I will do, I will, for sake of our convenience, I will put these dots, okay, instead of an allocation to avoid the confusion. Now I will calculate. I have given you all this value directly, and you need to solve it one more time, right? and the corresponding opportunities cost are also I have calculated for you. Now here you can see that all the opportunity costs are positive, so there is no negative value, and we can say that the whatever the present solution is there is the optimum solution. So in this way we can conclude that the present solution is the optimum solution. So thank you.